Okay, so we're going to go through expected value, and they've given us a question, and it looks like this. It says there are 2 defective RAM modules in a bin of 6. So essentially, we're pulling out of some bin. Make a 3-dimensional bin here, and we'll use circles to represent them. And we essentially have, we'll use these up. 1, 2, 3, 4 good working ones, and we'll say 2 defective ones. Okay, so this kind of gives us an idea. I should have made a nicer bin, but that's our visual for this question. The question asks, or the first question asks, what are the possible probability outcomes? So in terms of drawing, if you're a customer and you decide to draw, oh, I got to say how many we decided to draw, right? We decided to draw 2 at a time. Okay, so we're going to make 2 draws. We want to buy 2 RAM modules. So we're drawing 2. That's important for this. Drawing 2. So what are our possible outcomes? Okay, so let's go over our probabilities here. So we'll call a 0 essentially your idea of everything or not drawing any defective ones. Okay, so everything working. So essentially that's the idea of drawing, use our visuals again. Is this the right one? I think it is. 2 of these, okay? Of drawing 2 of those. And what's the probability of this event happening? So because there's 2 draws, we'll do our first draw in purple, okay? So we'll call it D1. And what's the probability of drawing a one that works? Well, we can see here there's a 4 in 6 chance on draw 1 of picking, that's a 1, of taking a non-defective one. And then there is a 2 in 6 chance of taking a defective one, right? We'll use our little colors there. So that's our non-defective, that's our defective. So that's on draw 1. And then draw 2 is going to change for each of them. So let's say we take one that's not defective. That's a 4 in 6 chance. Okay. And then we have draw 2. Well, draw 2 here is a little different because something's been pulled out, right? And technically it's a non-defective one. So in draw 2, our probabilities changed. Because we already took one of the non-defective ones, essentially one of these is gone, there's only 3 non-defective ones left, and there's a total of only 5 because we've already taken one out, okay? And of defective ones, that probability is also changed. There's still technically 2 defective ones left because we never drew one out, but there's only 5 total to pick from, okay? In this one, we decided that we're going to take 2 non-defective ones. So that's our 3 in 5 chance. So we need to multiply those ideas together. Let's move this all over here. Okay. So when we go to multiply this together, we take 4 by 3, which gives us 12, over 30. Okay. So that's the probability of taking no defective ones. Now there's the probability of taking 1 defective one, and we're going to do these in order because there's technically 2 ways we can do this. In our first one, we take one that works, and then our second one, we take one that doesn't work. So with that same idea, in our first draw, we take a non-defective one. Well, we already know that probability of that is 4 in 6. We established that in draw 1. In draw 2, though, this is a little different. We've decided we are going to take a defective one, and this is the probability of taking a defective one in draw 2, a 2 in 5. So when we multiply the probabilities together, that gives us 4 times 2 is 8 over 30. Okay? But there's another option. We could also draw one in the reverse order, where we take a defective one first and then a non-defective one. Okay? So we'll look at those probabilities. We know in draw 1 the probability of taking 1 defective. Okay. So this is a little different. Our first probability, we take a defective one. We know we have a 2 in 6 chance of doing that. And then the probabilities have changed. This is our other draw 2, we'll call it, okay? Because we technically have 2 options in draw 2. We'll call this the green option. Because we haven't taken any defective ones out, there's still non-defective ones. There's still a 4 in 5 chance. But in our other option of defective ones, where we have taken one out, we only have a 1 in 5 chance of drawing defective ones. And that's important here. So this is the other option, draw 2, where we take a non-defective one, that's a 4 in 5 chance. So then we multiply the 2 of them together. 2 times 4 is 8, and 6 times 5 is 30. Okay, so these are the we have to put these together to actually find the probability of drawing 1. Okay, and finally, when drawing 2, there's the possibility that you draw 2 bad ones, right? And when you draw 2 bad ones, well, your chance on draw 1 of drawing a bad one is 2 in 6. We already had that. And our chance to draw 2 of drawing a bad one, if you've already drawn one, is 1 in 5. Okay, so we're going to multiply these together. 2 times 1 is 2. 6 times 5 is 30. Okay. So, and I'm going to just put these two together. When I add those together, that'll give me 16 over 30. So these are our possible probabilities. Oh, great. So of drawing 0, you have a 12 in 30 chance. Of drawing a 1, okay, you have a 16 in 30 chance. And for drawing 2 defective ones, you have a 2 in 30 chance. And to make sure they're correct, we should add the probabilities together. So 12 and 2 is 14, and 14 and 16 is 30. So that's 100%. That covers everything. Does this make sense how we built the probabilities? Yeah? So we've built the probabilities. Now we've got to find the expected value. And the expected value is where we take the values, okay, the sum of them all, our expected value of x, and we multiply them by the probabilities. So of getting 0, so our x being 0, so the idea is x times the probability of x. Okay, I should have put a bracket there. And we'll call it x1, probability of x1, plus x2 times the probability of x2 all the way to the end. Okay, so for us, our x1 is our value of 0, and the probability of getting 0 is 12 and 30. Okay, and we'll add those together. And that was essentially what we did in orange here. Oops, wrong button. Let's do it orange. Okay, does this make sense? Mm-hmm. Okay. Then for our second one, our probability of getting the value 1. Well, we have a value of 1, and we remember the probability was 16 and 30. And then finally, the probability of getting a 2. Well, it's 2 times 2 and 30. Okay, and I'll just highlight them for us. The second one was pink here. So these were our pink values. And the last one were green values. Okay. So with that being said, we just have to carry out the operations now. 0 times this value will give us 0. 1 times 16 over 30 is just going to give us 16 over 30. And finally, 2 times 2 over 30 is going to be 4 over 30. Does that make sense? Mm-hmm. Okay, 4 over 30. Because these are already, well, 0 we can kind of cancel out. 16 and 4 is 20 over 30, which is a 2 and 3. Whoops. I was thinking of the decimal. Which is approximately 0.6 repeated. So your expected number of defective products is 0.6 repeated. So that is your expected value. The hardest part about this question was building the probabilities because we had 2 different draws every single time. It made it much more difficult to work with.